So in this lecture, we're going to talk about the map interface in Java. Now, this map interface in Java is different than the map interface you see in your textbook. They're slightly different and slightly similar. What you see here on the right side is my drawing illustrating the map architectures in Java. So on the very top, there is a sorted map interface which extends the map interface. Okay, there are three concrete classes here: hash, linked, and tree maps. Now, Hashmap implements map, right, as an interface. Your tree map implements sorted map as an interface. However, your linked Hashmap, which is a specialized version of Hashmap, extends from Hashmap, right? So linked Hashmap basically has everything that Hashmap has, basically has everything that map provides. Okay, the tree map here. Tree map doesn't have anything that Hashmap has. Okay, it doesn't have anything that map has. So tree map actually takes a different circuitous route. In fact, this is a simplified version of your class diagram here. And tree map actually implements navigable map, which extends sorted map here. I eliminated that stuff here. Now, there's a couple things that you want to take away from here. One is your map is an interface, right? So it can only be used with a class that implements the interface, right? So this is the reason why you see map and hash map, they're together, right? In lots of industry codes. Tree map here, right? With the sorted map. Now, sorted map is a interface, which means that sorted map can only be used with the class that implements this interface. This is the reason why you see tree map and sorted map together, right? In industry code as well. Now, linked hash map is a trial of hash map, so it could be used in map. So that's why so these are the high level differences, and this is your first time looking at this. You can do a little bit of study on this. There's a ton of literatures online, and also Java Doc can give you more information about this. And some of you probably had this too in your advanced data Java class, but let me just do a quick illustrations. So recall that all of your data structure, including map, they're located in what's called the Java util package. So what I did here, oh, by the way, this is your replit. You can either have an account with it or not. I logged into my account. So I'm running it off of it as a main.java class. So this main.java has to have the same name as the main, right? As the name of the file. Let me just do a Java import util. And using a wildcard, this basically means that I'm exposing the entire package to this entire, whatever the solutions I'm writing here. So I don't have to keep on importing a specific one since I will be using map and hash map anyway. So for this illustration, let me just do a quick map and hash map illustrations here. We will leave tree map and sorted map illustration, some other time. So quickly, there are two ways you can create a concrete hash map using map. One is to use the default, and the other one is that you would use a generic. Okay, so let's just quickly kind of go through this. And for some, this might be a refresher. In order to create a Hashmap interface, I have to use my map as an interface. And now this map interface takes two value. One is a key, the other one is value, right? So the key and value, using a generic, they have to be a concrete class, okay? So let's just say we want all of our keys to be integer, right? Like 1, 2, 3, 4, 5. All of our values be a string. Now, to do this in generic, you have to create integer class and string class, and make sure that you pass them in. I'm just going to call it hash map, okay? And now this is where we can create a concrete class. Now, you have to use a concrete class to define, right, this hash map, which is off of their interface map in Java. This is what's called interface polymorphism. Now, using a default initialization of a map, you don't have to specify your key value data type. Now, the difference between specifying versus not specifying is that when your hash map concrete class is created, this key and value, they don't have to be tied to an integer class or a string class. What string? There's not another string class, but from the key perspective, your integer key does not have to be of integer class. It could be a primitive like int instead, right? So this is the reason why you don't put int here. Okay, so that's kind of given, but in your hash map you can insert int. So this creates a hash map here. Okay, and let me just do a couple of insertions. So to insert a value inside this hash map, you would invoke this method called put. So this put gives you the ability to input key value pair. And so this is what I'm going to do. Your key and value pair, your key does not have to be an integer class. It could be a primitive because this hash map is not enforcing here, right? So this means that you're not enforcing the type. Okay, so if that's the case, your very next one, your string has to be a class, right? And this class, let's just create it like so. Data structure, okay? And 2. Now let's just print this system out print line. Sometimes when we type too fast, it just kind of blues over. Let's run this. So we should be able to see an hash map representations here, and this is inside a curly braces here. 1 equals data, 2 equals data. So key is 1, value is data, key is 2, value is structure, and it's concatenated using and this this comma right here. Okay, system out print line basically prints the hash map to string. All right. Another way of creating a hash map is to use generic that enforces the type, right? Basically, what you want to do is to match the type of your map interface with the types what's in the map interface. So the way to do that, I don't want to type this whole out. Let me just kind of copy this whole thing and just make changes. Since we use hash map already, let's just use hash map 1. So I want to enforce my integer here and my string. And the way to do that is we'll have to fix it. First of all, this is hash map 1, right? And this is hash map 1. I want to fix my key to be an integer class. So this is what you have to do in order to get this to work. Okay, let's run this. So you should be able to see 2 lines. They're all the same. So basically, one enforces the type of your key, and the other one does not, right? In both cases, we have our values being a string, so that's not a problem. Let's just say, with this enforcement with the generic illustrations here, we don't want to use, we violate the type, right? Let's see what happens. And let me also clear what's on the right side so you can see this better. We should be seeing some errors here, right?